Welcome. In this video, we will explain the basics of semantic search in a document database via what is called RAG, Retrieval-Augmented Generation. Please note that I use the term transformer to refer to ChatGPT from an LM for a large language model, or its equivalent. When you ask a question to a transformer, this model formulates a response by leveraging the knowledge acquired during its training. This knowledge is entirely stored in its internal parameters. But to answer the question concerning the results of last American presidential elections, the transformer trained until April 2024 does not know the answer. If this technology makes it possible to generate high-quality response, the disadvantage is that updating knowledge is not easy. However, several methods are available to us to achieve this update. The first method is adding knowledge directly into the prompt. However, transformers have a limitation related to the size of the input prompt, even though models are constantly improving to push this limit further. The second method involves overtraining the transformer, which requires carefully selecting a large amount of data and mobilizing significant hardware resource for several weeks. The third method, through partial retraining of the transformer, modifies only a few % of the model's parameters, but it still requires running hardware resources for several hours, so we are far from a fast update. Finally, the fourth method, the RAG, which is the subject of this video. Here is the general idea. Let's imagine we're browsing Wikipedia to collect the key facts since April 2024. This data includes the Wikipedia page for the last presidential election. So with a RAG, we'll start by breaking down the entire text into small pieces. Next, each piece of text is encoded into a vector representation using the encoder part of a standard transformer. Each piece of text gives us a vector represented here by a color. This vector is a mathematical representation of semantics, independent of a language in some way. These vectors are of fixed size and consist of several hundred dimensions in practice. Here, to simplify the representation, these vectors are projected into a two-dimensional coordinate system. Next, we encode the question with the same encoder. Thus, using a mathematical distance, we find the text passages that most closely match the question. In a final prompt, we can then add to the question the most relevant pieces of text from Wikipedia related to the question. Thus, the transformer trained until April 2024 can then correctly answer a more recent current affairs question. Note that in the original article describing the RAG from 2021, the article mentioned an encoder specifically trained for the question and for a particular theme. Today, with the advancements in transformers, most naive implementations use the same standard encoder for the question and the documents. Likewise, the generator part is replaced by state-of-the-art transformers like ChatGPT. We will now implement this example in Python with the library LangChain. You could easily recreate this example from LangChain examples. After setting up a Python interpreter, we declare the necessary libraries to run this example. Declare your OpenA key to use their transformer from the cloud. We create the object that allows the transformer to be used, BI providing text. The object returns a vector called embeddings. Here we create a list of documents that we fill with a string language utility. This object is the utility provided by LangChain to split documents into text pieces. By adding the list of documents, the utility returns another object representing the text pieces. Here we are creating our vector base by providing the text pieces and the transformer. There are several vector base implementations corresponding to your needs in terms of document base size. In this naive example, all will fit into a computer memory without any problems. Here is the question to ask our target document database. We perform distance calculations based on our vector database in relation to the question. Once the distance calculation is complete, we can perform the sorting by the nearest distance to retain only the most relevant pieces of text. Finally, we initialize ChatGPT to use it as a generator. The final prompt is assembled to submit the final question and the pieces of text containing the answer, the prompt does indeed contain the piece of text providing the result of the presidential election at the top of the list. So, the request returns a correct answer formulated in natural language. Of course, in an industrial application, a company's document base can be much larger, which is a primary factor in increasing the difficulty of finding the answer to a question. The cause of failure of the RAG may be related to the fact that an underlying question may require broader knowledge and complex interdependent links. In a branching structure, this escapes the flattened structure of the basic RAG. In the next episode, we will test the state-of-the-art in RAG with the trial of Light RAG, which provides a solution to the scalability issues of Microsoft's Graph RAG. See you soon in the next video.